A mole is what we're going to investigate next. A mole is a number. When we refer to mole, we're referring to 6.022 times 10 to the 23 of any article or any unit, something that comes as a particle. We call this number Avogadro's number, and we use mole in the same way that we use dozen. For instance, if I say dozen, you automatically think 12. And if I say a dozen donuts, you think 12 donuts. We can do the same thing with mole. I can say mole is equal to 6.022 times 10 to the 23, and if I were to say a mole of donuts, well then you would think 6.022 times 10 to the 23 donuts, which is an incredibly large number of donuts, which would be a volume almost the size of the Earth. It's really rather hard to grasp the size of this number. Very, very large. But we have to use such a large number when we're counting things like atoms, because we can't count atoms in numbers of 12. They're just too tiny. So we count them with a really huge number, like 6.022 times 10 to the 23. We can use this word, mole, and this number with things that come as units or particles. Just as we wouldn't say a dozen grams, it makes us feel uncomfortable because we're used to using dozen with things that we count as items, like a dozen people or a dozen dogs. We don't use dozen with something that comes with a decimal. Likewise, we don't use mole that same way. You never have 6.022 times 10 to the 23 grams. We don't measure grams with that word and number. We only use it for counting things like atoms or ions or something that comes as a particle. So a mole is 6.022 times 10 to the 23 items. So we can use the word mole with atoms or molecules. If you have 1 mole of carbon atoms, well then it's going to be 6.022 times 10 to the 23 carbon atoms. If you have a mole of water molecules, well it's 6.022 times 10 to the 23 molecules. We know what we're dealing with, whether atoms or molecules, based on the symbol. If I look at a mole of carbon, I know carbon comes as atoms, so I would put atoms over here. If I look at a water formula, I know that comes as a molecule, so it would be molecules over here. If I look at this relationship that I've looked at, that we've been talking about so far, you can see we've been writing an equal sign. Anything that has an equal sign in it can be used to form a conversion factor. So I can take this and write 1 mole is 6.022 times 10 to the 23 atoms. If I'm dealing with atoms. If I'm counting molecules, of course I would have this, instead of having atoms in the conversion factor, I would have molecules. But you can see that this is a conversion factor and we can use it to do mole conversions. Here's an example. How many moles is 2.4 times 10 to the 22 atoms of lithium? The first thing that you're going to want to do is write your conversion factor. Now, a mole is 6.022 times 10 to the 23. We're dealing with something that comes as atoms, so we will put atoms after the number 6.022 times 10 to the 23. So down here, I'm going to write my given, and then I'm going to orient my fraction, my conversion factor, so that atoms cancels out, and I go to mole. Now you can see that 6.022 times 10 to the 23, the large number, is with atoms. We never have any number with the mole, or it's an unwritten one. This 6.022 times 10 to the 23 must always be followed by something like atom or molecule. Don't get mixed up on this. Always have 6.022 times 10 to the 23 with either atom or molecule and no other unit. So we do this math and we come up with the number of moles of lithium as being 0.0040 moles of lithium. To enter this in your calculator, you're going to be putting in 2.4. Do not press a times or a 10, just press the EE key, and then 22, and then do divided by 6.022, EE 23. When entering in scientific notation, do not press a times and do not press a 10. That way, the number goes in as a unit and you end up having your math done correctly. If you happen to put a times in this math, you're going to come up with a very large number and be confused. If you do not get the answer to this problem correctly done and get 0.003985 in your calculator, then you either need to see someone who does know how to use a calculator or bring your calculator to me and I will show you how to use it. Now what I'd like you to do is to take the principles that we just covered with moles and number of atoms and do the following problems, figuring out how many atoms are in 2.89 moles of aluminum and how many moles are in 7.2 times 10 to the 22 atoms of helium. Pause and then press resume after you've finished the problems.
To do this first problem, you write your given, 2.89 mole aluminum. Then you write your conversion factor so that mole cancels out. So mole must be in the denominator and atom in the numerator. The fraction must be equal to 1, so you put 6.022 times 10 to the 23 with atom. Note, do not write 6.022 times 10 to the 23 with any other unit other than atoms or moles. Moles cancels out and you do your math, 2.89 times 6.022 times 10 to the 23, and that will give you 1.74 times 10 to the 24. If your calculator is not giving you 1.74 EE24, then you're using your calculator incorrectly and you need to see me with your calculator and I will show you how to properly use it. To do the next problem, you're going to write your given, 7.2 times 10 to the 22 atoms. Then you're going to have to write a fraction so that atoms is cancels out and you go to mole. So that means that atoms must be in the denominator and mole in the numerator. In order to make your fraction equal to 1, you need to make 6.022 times 10 to the 23 be with atoms. Atoms cancel out, and that gives you 0.12 mole.
Now, why is this mole number important? The reason that mole is important is a gram is defined as being 6.022 times 10 to the 23 AMUs. So, if I have 1 gram, I have a mole of AMUs. Now let's look at how this plays out with an element. If I have a mole of hydrogen, well then I have a mole of the mass of that atom, which is 1.00797 AMU. If I rearrange this and replace mole with the number 6.022 times 10 to the 23, you will see really that I have 6.022 times 10 to the 23 AMU times 1.00797. That means I have 1.0797 grams. What we can do when we go to the periodic table is pick any element and find the decimal number, and if I take that decimal number and follow it with gram, well, that is equal to a mole of that element. This allows us to weigh out moles of any element by using a balance, which is the only way that you can count atoms. This is very similar to going into the hardware, and let's say you needed 5,000 nails. No one's going to count out 5,000 nails for you, but the person who runs the hardware will know for a particular size nail how many of them weigh how much. And so then he can weigh out 5,000 nails by knowing that. Same thing happens with atoms. Using this relationship then, I know that I can use mole, the relationship between mole and mass, using the atomic mass. I can create a fraction for doing a unit conversion. I can write down that 1 mole of any element is equal to its atomic mass in grams. And then I can form a fraction which has mole on one side and the atomic mass in grams on the other side. And then I can use that fraction whichever way I need to flip it in order to get unit cancellation. Let's look at an example of how you would do that. If I have 0.0040 moles of lithium and I want to know how many grams there are, I create a fraction going to the periodic table and seeing that written for lithium is a 6.941, a decimal number. I take that decimal number and I put grams after it and set it equal to 1 mole. I can form a fraction now with mole on one side and 6.941 grams on the other side. Always make sure that mole has either a 1 next to it or no number at all, an unwritten one, and that the atomic mass is written with gram in your fraction so that you come up with the correct setup. When I go to do this problem here, because I'm wanting to cancel out mole and go to gram, I orient my fraction so that mole is in the denominator to cancel out mole with lithium, and then I have grams in the numerator. They cancel out and give me this product. Now what I'd like you to do is to pause the lecture and try these 3 problems and press resume when you're through so you can check your work.
To do this problem, the first thing you're going to do is write 0.2 mole, and then you're going to write a conversion factor so that mole cancels out and you go to gram. In order to make the fraction equal to 1, you go to the periodic table and you see that the atomic mass of calcium is 40.08. So that goes with the gram in the numerator. Notice the decimal numbered of the atomic mass always is with gram. You then enter this into your calculator and you'll get 0.2 times 40 will give you 8 grams. To do this problem, we start with 5 grams as our given. We orient our conversion factor so that gram cancels out, so it needs to be in the denominator, and mole is the unit that ends up being remaining after the math. We have to make our fraction equal to 1, so we look at the periodic table and we see that iron has a molar mass of 55.845 grams. So we enter the atomic mass in there as the molar mass, and grams cancels out, and in our calculator we will get 0.090 moles. How many grams is 250,000 atoms of gold? We start our math with the 250,000 atoms. Our units, we cannot go directly from atoms to grams. We have to go through moles. So we can go from atoms to mole, and then we can go mole to gram. We have to make each one of these fractions equal to 1. So the number that goes with atoms to go to mole is 6.022 times 10 to the 23. And the number that goes with gram to make it equal to mole is going to be the molar mass of gold. So we enter in 6.022 times 10 to the 23 with atoms and 196.97 with grams. We do our math, and you see atoms cancels out and mole cancels out, and the number that we get on our calculator is 8.2 EE negative 18. Of course, we do not write 8.2 EE negative 18. We're going to write 8.2 times 10 to the minus 18 because EE is calculator speak. It is not a number. If you did this math exactly as it is here on the page and you're coming up with a different number than 8.2 times 10 to the minus 18, then you may be using your calculator incorrectly and you need to bring it to class, and I will help you use your calculator correctly.